Assalamu alaikum. My name is Khadija Jameel. I'm a medical student at Dow Medical College, and in this presentation, I'll be talking about quality assessment. So, at this point, I believe you guys have gone through your basics, the introduction, the writing part, the analysis itself, but now we will be moving on to one of the most important parts of your research, which is quality assessment. So, basically, quality assessment is like you tell something a fact, and the person's gonna ask you, why should they trust you, right? So, the only way you can prove that what you're telling is correct is by showing them the reliability. So, quality assessment, it assesses the quality of evidence that you're giving in your data. So, there are two important tools which help you do this step, which I'll be talking about in detail in the coming slides. But for now, you need to understand that this step is very important, and how does this really show up in your research article is something like this. So there's gonna be a paragraph on data extraction and quality assessment, or you can just give it a separate heading. And then in this step, you need to understand that this is done on an individual basis. So if, let's say, 4 people are involved in your research, 2 or 3 of them are going to assess the quality of your article individually. They won't be doing it together or in a team or in a group. This is just to ensure that there is no additional bias. And as you can see in this example, the way it is stated, 2 reviewers independently assess the quality of included studies using the Newcastle-Ottawa scale. So I'll be telling you what that actually is. So we have 2 main tools for quality assessment. Number 1 is Newcastle-Ottawa scale for observational studies, and there's another tool called risk of bias tool, Cochrane tool, which is used for randomized controlled trials. So on the basis of study that you're doing, you're going to select the appropriate tool. So let's say you're doing an observational study, let's say you're doing cohort or case control study, you're going to go for NOS. And if you're doing a randomized control trial, you're going to go for the ROB Cochrane tool. Like I said before, this is going to be done independently by the researchers. So first, I'll be talking about Newcastle-Ottawa scale. It's again used for non-randomized case control cohort studies. And I like to think of Newcastle-Ottawa as, when you go to a restaurant and you're giving a feedback, you use the star system. So either you give 3 stars or 4 stars, or if it's really a good restaurant, you end up giving them 5 stars. So this is basically what we are doing in this step. You give stars to the research on the basis of 3 criteria. So number 1 is selection, number 2 is comparability, and number 3 is outcome. So we're going to assess these 3 things, and on the basis of these 3 things, we're going to give them a star. And the more stars your study have, the more reliable it becomes. Okay, to understand these 3 criteria, I will be explaining each one of them. So let's go start with selection. So whenever we're doing a research, the first step is the selection. So the participants in your research, they have to, be appropriate for the topic that you're going for. So let's say you're doing a research on effect of smoking on lung cancer. So you will be taking individuals who are exposed to, they're either active smokers or either passive smokers, to really understand the impact of those carcinogens, right? So that's where selection comes. Did you take the appropriate sample size? Did you take the appropriate people in your sample? So both the groups, exposed and control, should be taken adequately. So let's say if you're doing a research on the same topic that I told, the lung cancer one, you won't be taking some people from, let's say, Pakistan and another group from Africa. You will be taking them from the same area, because obviously the genetics and the environment, they also play a role. So that also come into play. Okay, so number 1, representative of the exposed cohort. Number 2, selection of the control group. If they're taken appropriately, they will be given a star. And the more stars it has, the lower the risk of bias. Then come to comparability. So on the comparability, is basically you have to take 2 comparable groups. if you are studying the effect of smoking on lung cancer, you're going to take people from the same age groups. You won't take one group from, let's say, 6 to 12-year-old, or another from 50 to 60-year-old. That is going to create a huge bias. So whatever groups you're comparing, they should be adequately selected. And then comes the outcome. Okay, so whenever we're assessing the outcome, we have to make sure that we're not really biased, because that can impact the result. So number one, assessment of outcome, adequate blind assessment of record linkage. And then we're going to look at, was follow-up long enough. So let's say you're studying the effect of a drug, let's say isoniazid for tuberculosis. So we're going to make sure that there was an adequate amount of follow-up that was done to really understand, to really, record the results. If there were incomplete follow-ups, or let's say if this drug, for a specific drug, you need to take the follow-up every 2 weeks. If those follow-up aren't done every 2 weeks, they're going to create a huge bias to your study. So you need to mention the number of people that were lost to follow-up, the number of people whose complete follow-up was done. This is, again, just to ensure that your data is reliable. Okay, so this slide shows an example of the starring system that I just explained. So I won't be discussing them in detail again. You can just see how how all the categories have been starred once they're found in the article. Okay, now let's move on to another quality assessment tool, which is Cochrane Risk of Bias tool. This tool is used for randomized controlled trials. And in this, we're not going to star the research. There are two methods. So either you can take the percentages, or you can just use this tabular form where you're gonna, grade each steps, basically. We're gonna go through each step. So number one says sequence generation. So in a randomized control trial, the important aspect is that neither the researcher nor the participants involved know the drug. For example, if we are, let's say there's a new drug in the market, XYZ, we want to see the efficacy of or let's just say we are looking for the results of Tylenol, which is a painkiller. So we're going to make two groups, A and B. Let's say the group A was given Tylenol and group B was given a placebo. So the sequence generation has to be totally random. We won't be, there should be no bias involved in the grouping. And if there's no bias involved, they will be given a green plus, like in this tabulated form. Then comes the allocation concealment. Okay, so in allocation concealment, we're going to evaluate the method that were used to conceal the allocation sequence. So basically nobody, nor the researcher, nor the participant involved, or any other person in the research involved must know about the allocation. So you basically have to conceal or hide that allocation. Then blinding, which is basically the same, that neither the researcher nor the participants are, they're not known about what drug they're given. And then incomplete results. So let's say there were 20 participants involved in a group, and only 15 of them, only the 15 results were available. So 5 of them were either incomplete. So they're going to create a risk of bias. So we're going to make sure that there are very less incomplete results, or no, for more accuracy. Then comes selective reporting. So if the researcher involved in the research was not able to completely report the results, or there were, for example, if there were 20 participants and he was only able to report 15 of those results, and 5 of the results got lost, or could be any other reason, that could also create a bias. So we have to make sure there shouldn't be any selective reporting. Complete data should be reported to make sure that it's very accurate. And then there could be other biases apart from the one that I already mentioned. So these are the 7 things we're going to look for while we're using the Cochrane tool. This is another example in which they have given percentages. So this is another way you can do. or just using this tabular form. So this was the end of my presentation. Thank you.